Welcome back, everyone. On this type of problem, I want you to be able to read the instruction very carefully and observe your dimensions carefully. If we read this question here, it says that the diagram below shows a concrete tank. Now you know that we're going to talk about a concrete tank that has the following dimensions. The fact that we're talking about a tank, meaning that this type of a shape should be a cylinder. The height of a tank is 85 centimeter, meaning that we measure from the bottom. This bottom is also this bottom is also the circle, and the area of the circle is pi r squared. So we measure from the base. I normally call this the base side, this object. So the height is when I measure from the base, I go up the highest point. This is now my height. Then we come here. It says that the width of the wall of the tank is 20 centimeter. The width of the wall of the tank is 20. So the student should be able to see this on a diagram. This is the measure here. That's what they mean when they say the width of the wall. It's from here up to here, from here up to here. Inside the diameter, 160. Inside diameter. So let me show you what do you mean by that. I can even grab a ruler there. Let me take my ruler here. I want to make sure that I underline it correctly. I want to show you how we measure the 160. The 160 is the distance from this part here up to this part. So it's the distance here. You see that? That is actually 160. Maybe you want to know the distance from, let me use a red pen. Maybe you want to know distance from this wall coming to this wall. The student should be able to see that this distance that I've just underlined now, it's a combination of the two numbers, which is 160 centimeter plus 20, which is this 20 here, plus another 20, which is this one here. Then when we add these two numbers, we are going to get 200. This 200 is the distance from this wall up to this wall, which is 200 centimeter. Maybe I should repeat my observations here. I'm saying that the width of the wall of the tank is 20 centimeter is a measure of this distance from here up to here, here up to here. The inside diameter is 160. The diameter, when we talk about diameter, we're talking about the distance that joins the 2 points within a circle. But that particular distance must cut the center, which is 160. So we are given diameter, which is equal to 160. But if we want to get the radius, we take the half of 160. Then we're going to get the radius there, which is actually what? Grab your calculator there and say 160 divided by 2 and write that number down. You get 80. 80 is the radius of this circle on top. So it's the measure from here up to there. That is the R, which is 80 centimeter. So I think this observation is very important to you. Now, let's see what does the question wants us to do. Number A, determine the outside diameter of the tank. We already did. The outside diameter of the tank is 200 centimeter. The approach is the one that we've already used here. Then let's go to number B. Calculate the volume of the tank. So the student needs to realize that when we talk about the volume of the tank, we're referring to the inner space of the tank. The inner space of the tank is called the volume. And whenever we want the inner space of this tank, let me remove the ruler here. Whenever we want to calculate the volume or the inner space of the tank, we always consider the base side, which is the circle, which is pi r squared. We multiply by the perpendicular height. In this case, now the pi is given by 3.143. We multiply by the r. We already calculated the r there is 80. And then we write 80 squared. Then we multiply by the perpendicular height, which is 85 centimeter. It's here where you need to use your calculator to get your final answer. Maybe I should grab our calculator directly from my app. I'm going to say 3.143 multiplied by 80 squared to go down 80 squared. Let me delete this. I start again. 3.143 I multiply by 80 squared is the same as saying 80 times 80. Then there I have to multiply by 85. So I obtained this number here. It didn't disappear, I still have it here. 1709 792 1709 792 792. This is a volume, should be measured in cubic units. So this is how we solve this type of problem. So firstly, you need to recognize that the volume of the tank refers to the inner space. Because of we are referring to inner space, that's why we take the inner diameter so that we can get the inner radius. Having done that, we have to correctly substitute our r and be able to correctly substitute the perpendicular height and make sure that you are able to do the correct multiplication there and correct unit. I can give you 1, 2, 3, 4, 5, 6, 7. Can give you plus or minus 7 in this problem. So now we're going to do number C. On number C, we are required to calculate the volume of the concrete wall. The volume of a concrete wall. Now here, I'm going to remove all this. I want to calculate the volume of the concrete wall. I can grab a pen there, number C. The volume of a concrete wall will include this distance from here up to here, from here up to here. That will be the diameter. Which is 200. It's the one that we've calculated there, which is 200. Now the R will be the 200 divided by 2, we get 100. This 100 here is nothing else but the radius of the concrete wall. The radius of the concrete wall. Then we now calculate the volume. The volume is always given by pi r squared multiplied by height, where pi is 3,143 multiplied by, I need this space here, multiplied by the r is 100 squared times the h is 85. Then you do your calculations there. Please take your calculator and calculate with me there. We have 3.1 multiplied by 100 times 100 times 85 equal to, then we obtain 26. 26 what? 26 71,550. And this must be measured in cubic units. So this is how we calculate the volume of the concrete of the wall. Please watch this video again and make sure that you do this thing step by step with me. Take your book and a pen and the calculator, get your hands dirty, do the calculations with me of this question, and make sure that you feel free to repeat this type of problem more than once or 3 times or 4, even 10 times if you want to, until everything that we did here makes sense to you. I thank you again for watching. Let's meet on the next session. On the next session, we are going to do page 101. The focus will be on number 10, where we'll be calculating the volume of the cylinder.